Alright, welcome to our second video for geometry. This is problem number 13 from 4.4 worksheet. So this is coordinate geometry. We're given each set of vertices. We need to sketch the graph and then determine whether or not the quadrilateral JKLM is in fact a parallelogram, a rhombus, a rectangle, or a square. So we will need to use the distance formula and the slope formula. So the key kind of hints that they give us are things to remember is in a rectangle and a square, diagonals are congruent. In a rhombus and square, diagonals are perpendicular. So their slopes are negative reciprocals of each other. So I've already taken the liberty to plot. These were the points. I've plotted them. And so the first thing we're going to do is we know with diagonals, with that first hint, that if this is in fact a rectangle or a square, those diagonals are going to be the same. So we need to use the distance formula to determine the length of these diagonals. So recall the distance formula is equal to x2 minus x1 squared plus y2 minus y1 squared. So we'll first find JL. So JL, the line segment, the 2 points we're using here, just so I can label some points. We have -4, -1, and L is 4, 3. So this is x1, y1, x2, y2. So taking the square root, we have x2 minus x1, so we have 4 minus a -4 squared, plus y2 minus y1, so 3 minus a -1 squared. Simplifying what we have on the inside, 4 minus a -4. When we subtract a negative, we're actually adding. So we have 8 squared plus 3 minus a negative. Once again, we're actually adding, so we have 4 squared. So that gives us the square root. 8 squared is 64. 4 squared is 16. So when we add the two together, we get the square root of 60. So that is the length of JL. So then we need to find the length of the other diagonal. So we have MK. Right, the 2 points that we used here were -1, 3, and K is 1, -1. Right, and so using the distance formula once again, labeling my points first, I guess. So we have x1, y1, x2, y2. So x2 minus x1, we have 1, and we're subtracting our x1, which is a -1 squared, plus y2 minus y1, so -1 minus 3 squared. Simplifying what we have, subtracting a negative, we're adding, so we have 1 plus 1 is 2 squared, plus -1 minus 3 is a -4 squared. So 2 squared is 4, -4 squared is a positive 16. That gives us the square root of 20. So that is the length of MK. So these diagonals are different. So we know for a fact this is not a square, it is not a square or rectangle. But now we have to prove whether or not it is a rhombus or just a parallelogram in general. So how we're going to do that is we know, based on this little hint here, in a rhombus and square, we'll kind of forget about the square since we know it's not a square, but in a rhombus, diagonals are perpendicular. So perpendicular refers to the slope of a line, so we're actually going to need to use the slope formula. Remember, slope is equal to y2 minus y1 over x2 minus x1. So we're going to find the slope of the diagonals. So the slope of JL, let's once again write down our points. So we label this. So -4, -1, 4, and 3. Alright, so we have x1, y1, x2, y2. It's not necessary that you relabel your points if you notice that we do have them already up here, but it just helps keep everything in order. So y2 minus y1, so our slope formula, we have 3, and we're subtracting a -1, all over x2 minus x1, so 4 minus a -4. So 3 minus a -1, we're actually adding, and we get 4. 4 minus a -4, adding, and we get 8. So we have 4 over 8, which we can actually reduce to 1 over 2. So the slope of the line JL is 1 over 2. All right, so then the slope of our other diagonal, we have MK. Put a line segment over that. Once again, our points for MK, just moving my paper up here, our points for MK were -1, 3, and 1, -1. Labeling these x1, y1, x2, y2. So then using our slope formula, y2 minus y1, x2 minus x1. So y2 is -1 and we're subtracting a 3 all over our x2 minus x1, so 1 minus a -1. Simplifying, 1 minus 3 gives us a -4, and then we have 1 plus a -1, which gives us a +2. So a -4 divided by a +2 is a -2. So if you notice, if we compare the two slopes, -2 and a +1/2, notice they are in fact negative reciprocals of each other. If we were to, a reciprocal, once again, is we flip the fraction upside down. So this is technically 2/1. And so they are negative reciprocals, so the slopes of those diagonals are in fact perpendicular. So this is a rhombus. So as long as you followed along, you'll get the credit for this and you've written everything down. Also at the bottom, please state where you were getting lost or where you were getting stuck on or you weren't sure where to start. Just 2 sentences. I'd like to know maybe why you didn't start this or why you had troubles.